Hi, everybody. Welcome to today's masterclass on programming with MATLAB. Thanks for joining me today. My name is Lauren, and I've worked for MathWorks for almost 35 years now. And I try to share my knowledge in classes like today's. You might find some useful MATLAB tips, as well as looking at a blog that I write on the MathWorks website called The Art of MATLAB. And another thing is in 2 weeks, we're going to do a more advanced session on object-oriented programming in MATLAB. So let's go. I want to talk about programming with MATLAB today. It's a sort of strange topic in some ways. And the reason I say that is because when someone first talks to you about MATLAB, they don't say, they usually say something more like, MATLAB, it's really great for data analysis. Or use MATLAB or MATLAB and Simulink. It's really great system for modeling. But you don't usually hear people say, use MATLAB. It's a great programming language. And yet, we actually spend a lot of our time actually what I'll call programming in MATLAB. And so I want to talk to you about MATLAB from that point of view today. So my objectives are to introduce you to programming with MATLAB from the point of view of the programming, the language a little bit. Hopefully many of you have used MATLAB and already enjoy some of that. And I'm also going to show you some of the development tools that I use that I find very helpful. In addition to that, I also want to demonstrate a range of programming styles going all the way from the command line where we're just doodling around and making a quick computation to doing something potentially more complex. And I'm probably not going to get all the way into the object-oriented part today because, as I said, in 2 weeks, I'll be covering that. But I certainly will talk about it a little bit. Okay. And I also want to show you how to program effectively in MATLAB. Well, what does that mean? I'll tell you as I go. And you will notice, hopefully, that we have some MathWorks staff on the chat in the channel that you're looking at. Please feel free to put your questions in there. They'll be able to help you almost certainly. Okay. So I want to show you how I use MATLAB to do some programming by actually doing running an actual example and creating some code for that. So what I want to do is I want to assess where is the best location to put some wind turbines. And so what I want to do is I want to estimate if I put a turbine here, how much power will it produce? And if I put it over here, how much power will it produce there? And so I want to try that in a bunch of different locations and then figure out where to put the permanent one, the one that's going to have the best return. So in order to do that, at first, I need to interactively explore the data. Let me tell you a little bit about the data that we have. And let me tell you a little bit about wind turbines, because if you're like me, at least me before I knew about this example, I did not know that much about wind turbines. So for our example, we're going to assume all of the test turbines are the same brand and the same exact kind. They're all the same thing. Okay. And what they are these towers. And at about 80 meters height, you'll find that there's 3 speed sensors. Now, what you don't know about me yet, perhaps, is that I'm a physicist by training. And so when I say speed, I mean speed. I don't mean velocity. Okay. So it's going to be measuring just the total speed and not a directional component there. And the reason we have 3 there is there's mechanical parts in these sensors. And so if you think about it, if like a hurricane rips through, 1 or more of them could get damaged. And we don't want to throw out an experiment because 1 sensor got ruined. And so what we try to do is have some duplicates there so that we might be able to get good information. Moreover, we need that information for at least a whole year. And the reason I say that is the wind is not constant, and it's different throughout the year. So where I live, it's windier in the summers and in the hurricane seasons, and it tends to be less windy some other times of the year. And also during the day, it's not a constant. There tends to be more wind a lot of times. right as after the sun's rising, you get a lot of thermal action, and you end up getting the wind dying down like it's sunset some of the time. So the wind is not going to be constant throughout all of this. So I've got my 3-speed sensors. They're at a height of 80 meters. I also have a temperature sensor at a height of 3 meters, which is about double my height. Okay, so we only have one there. First of all, it's not usually mechanical, so it's less likely to fail. And number two, if I had to, I could probably use the temperature from a weather station that's relatively nearby. For example, all the data that we're going to get are relatively near Logan International Airport in Boston. And so I could just use the temperature from there, and that would be probably a good enough proxy for what I want. So what I want to do is I want to look at the data and pre-process it from these different observation towers. And then what I want to do is find out how much time we spend with the wind between 0 and 0.5 meters a second, and 0.5 and 1 meter a second, and so on, all the way up to whatever top speed it is, because I need that information as well as how the turbine responds to power at different wind speeds. So if I come to the next slide here, what you'll see is if I want to estimate the average turbine power, I need to somehow estimate this integral, the integral of the wind speed distribution. So that's what we're trying to capture with our wind turbine, the data that we're getting. And then we also need to know what the response curve is for the wind turbine from the manufacturer. And I'll talk about both of these a little bit later. But for right now, I want to go back. So once I estimate the power, I want to do it again and again and again and again so I can compare all the different turbines that are out there. Well, I kind of want to do that, but I don't want to do it by hand. And so I'm going to want to see if I can automate anything. So I'm going to come over to MATLAB now. And in MATLAB, what I'm going to also do is I'm going to come to my current folder, and I am going to come into the, I always have this problem in the demos, and inside the demos, you'll see I also have another folder, and it's, let me make this just a little bit bigger for you here. It's called Wind Data Files, and you see I have a bunch of files there, tower locations 1, 2, 3, 4, 5, 6. I can have, that's just the few samples that I have right now. So let's actually open one of these outside MATLAB and see what's in them. Okay, and I know that's really hard to read, so I'm going to try to zoom in. Just maybe I don't want to open with Notepad. Let me open it. You know what I'm going to do? I'm going to go like this. We're going to open the current folder. I'm going to come into the demos, the wind data files, and let me open this instead with, well, I don't, it's fine. I'll open it with Notepad or Notepad, edit with Notepad++. Maybe that'll help me. Okay, so here, now I can zoom in. And now what you see is it looks like I have 5 columns of information here. I've got the date and time, and actually I forgot to tell you, but the data are recorded hourly. So we have that information. And then I have speed 1, speed 2, and speed 3. Those are these 3 columns. And then I also have the temperature here, and that's going to be in degrees Celsius here. Okay. So it looks like we have some negative temperatures in winter, which means it's below 0 or below 32 Fahrenheit. So it sometimes freezes. So now I get to think about this and I go, well, shoot, one of the things I never thought about when I told you before that I was thinking about the data is what happens if the sensor's not broken, but we had a lot of wet snow and it got inside one of my mechanical sensors and it froze. But then later on, it may get warm up and it might work again. So I might have to think about that when I look at my data, because as you know, data is not usually completely perfect. So if I wanted to, I'm going to just come to the command window first. If I wanted to, what I would do is I'd like to figure out how to read in the data. And I'm going to come over here to the home tool strip in MATLAB. And what you might notice here as we go from left to right is I can create new scripts. Oh, look. import data. That sounds like something I could use. So let me import the data. And I'm going to come into that folder. I actually have copies of files in the current folder. So let me use windata.txt here. And now these are the same data, but they're being shown the way MATLAB would see them by default. And let me make this all a little bit easier to see. I'm going to just make these columns a little wider. And what you'll see is the first column, MATLAB detected that it was actually a time. And so it offers to put it in a date time format. I could put it in a string instead, but date times are really, really awesome. So if you've been using a MATLAB a long time and you're using datester or datenum, please, please, please read the documentation and move to date time. It will save you a huge amount of hassle. Now it also says it thinks the file is tab delimited. If I don't agree, I can change that. It's saying use the first row as the variable name. I don't have to have that, but I'm going to. And I'm going to have the range be, well, now I've got the range. I'm going to reset this. So what I actually want to read here is, let me get all of it. And now I don't really want to maybe read in that first row there, but it's offering to put this in a table for me, and I don't actually want it in a table. I'd like to look at each of the variables separately. So I'm going to actually put them in column vectors here. And you see I have numbers for the 3 speeds and number for the temperature. Now, what if I actually have some data that's missing here? I get to decide what I want to do. I can either exclude a column with some missing data. Well, if I exclude a column, let me zoom in again for you. If I exclude a column with missing data, I'm going to actually wipe out that sensor for the whole year. I don't want to do that yet. What if I exclude a row that has missing data? Well, suppose the missing data is actually one of the speeds. Well, I have 2 more speeds. So maybe I could get a good enough answer with 2 speeds instead of just instead of 3. So I don't want to do that yet either. And I could also offer to replace it. And so what you'll see is I'm going to replace unimportable cells with nan, not a number. And now what I could do is I can import it into MATLAB. And now we can come over here and we can see all of the data that I've brought in. I brought in my 5 different variables. Now, I just told you that I know that the speed of the wind changes over time, but I don't actually have a very good feel for how it really changes. So if I were going to look at that, it wouldn't tell me whether I imported the data correctly or not. But I still want to make sure I did. So I'm going to actually look at time and temperature. And I'm going to come over to the plots tab here. And this shows me of all of the MathWorks products I've installed, which is a lot of them, all the kinds of plots that are suitable for the kind of data I've selected. Well, I'm going to just do a plain old plot. And if you're already a MATLAB user, you won't be surprised at what we see. Okay, one of the things I get is my plot. One of the things you'll notice is that in my command window and my command history, it put the command I needed. So if you're using a new visualization you've never seen before, it's a great way to learn. Okay, now if I were to show this plot, before we decide if the plot is telling us that I loaded the data correctly, if I showed this plot to my manager, Mike, he'd go, "Don't show me that." And he'd say that because I haven't told him enough information. So what I'd like to do, for example, is I might like to insert some things. So let me put an X label on, and we will put time, time. And you'll notice that we have about a year's worth of data there. And I'm going to insert a Y label, and this is temperature, and I can click. And of course, then I can insert a title, time versus temp at wind data. Maybe that's the station name. Okay. All right, so that's a little bit better. Now, if I think about wanting to do this again and again and again, what I might want to do is actually take everything that I've done here and save it in a way so that I could reuse this plot, of course, except for the wind data, but I'm not going to worry about that right now. And what you'll see here is if I look under the file menu of a figure, I can generate the code for that. That's really cool. So if I generate the code, what you'll see is I now have, wow, that's big. I now have, I'm going to make it a little smaller here. And now it turns out that where I am, it is October 7th at 11:15. And MATLAB just generated this, and it allows me to see the commands it used, and it used Y label, X label, title, things that you maybe already knew. And if I want to, I could save that so I could use it again. I actually kept a version that I automated another time, so I'm not going to worry about that right now. But I want to come back here, and now I'd like to see what's going on. And do I believe this? This is, remember, time versus temperature. Well, winter where I am near Logan Airport is in December, January, February, and so on. So if I come here and I say, let me zoom, I can come and zoom in this region. And sure enough, these are the lower temperatures. This is in degrees centigrade here. So here I have freezing, and I have colder temperatures there. And if I want to, I can come along and pan, and we can go towards the summer. And you'll see in the summer, I don't have temperatures that are that low. If I come back and zoom again a little bit more, you'll also see that as I zoom, my labels on the x-axis update. And so it's telling me, it's keeping me grounded about where I am in the world. So, so that's really nice. And now I can do that on regularly. Well, I had that data from the import tool, and I can imagine loading in, tower location 1, tower location 2, 3, 4, and so on. What if I have 100? I don't want to come back here and change all of those little things that I changed. And for example, I could change this. If I can come and change any variable name as well. So any of those things I change, it would be nice if I could commit that to something so that I could automate what I'm doing later as well. And if we look under the import selection, you'll notice, I don't know if it's going to let me do, oh, good. I can either import the data as I showed you already, or I could generate a live script, a script, or a function. Well, I want to generate a function because I imagine giving this a whole bunch of different file names. And so let's just take a look in the workspace. Right now we have 8,776 values for each of our things. Okay, so what I can do is let me just save this now. We'll save this as import file 1. And if I do help, whoops, import file 1, we see that it tells me when it got auto-generated, but it also has an example based on what I just did. So I can come here, and I'm going to pay. Oh, I didn't want to run it again, but I did. I just loaded it again. So if I look in my workspace, guess what? I have the same number of numbers. And in fact, I can come back there and I can do that plot again. Here, I'm just using the command line recall and typing a little bit, and it's finding me the last time it plotted that. And this is the same thing we saw, except for this isn't the version that, of course, is got the annotations on it. Okay, so I've begun to make this so that I can put together a story. And that's what I want to do. And I'm going to now go to something that I've created already. And this is now a live script. So let me just take a little digression for a minute. Before COVID, I used to travel around the world a lot and give lots of seminars and workshops and things like that for various customers. And I also visited many countries. And in many of these countries, I was not fluent in the other language. Only in a couple could I get by very well. But if I wanted to relax in my hotel room afterwards, what could I do? Well, I could always turn on the television and I could watch sports. I could watch nature. I could watch children's shows, and I could watch cooking shows. Because with all of those, even if I don't understand the language very well, I kind of have an idea what's going on. So you'll know if you've ever watched or even heard about cooking shows, what often happens. Someone will go, today we're going to make an omelet. And they break some eggs and they mix it up and they add some cheese and do whatever they're going to do. And they put it in the oven. And as soon as they put it in the oven, voila, what do? They take out one that's ready. And that's what I'm doing here. Here I have some final code that I'm going to use and we're going to go through. So what I want to do is I want to clean up my workspace and close all my figure windows. And for that, I'm using a favorite on the quick access tool strip, which often lives up here, but I have so many tabs open, it's hard to see. So I put it down below. And what I can do is I can show you one of my favorite shortcuts that I created. It's clears my workspace, clears the command window, and forces all figure windows to be closed. So if I run that, I just go like this, and now you'll notice that I have nothing in my workspace. So now I have this live script. Now, for those of you who have not used the live script, I want to introduce it to you and give you some information about it. You'll notice first that it doesn't end in .m the usual way that you're used to seeing MATLAB code. And yet I'm telling you, this is MATLAB code. But it's MATLAB code that allows me to format it well. So I'm going to make it a little bit bigger here so you can see. And you'll see that I can put in titles and label headings and things like that. I can also put in bulleted lists and numbered lists, and I can center data wherever I want. And I'm going to show you a few things as we go. But one of the things I can also insert is I can put in an image. If I had an image of a wind turbine, maybe I would put one in. If I had a link to where the data is coming from, maybe I'd put that in. And if I wanted to, and I don't have anything to put here realistically right now, but I might want to show people the equations that I'm using. And so for that, I can either use the LaTeX equation editor. Guess what? I'm not very good at LaTeX because it didn't exist when I was in grad school. So I'm going to use the equation editor here, and I'm going to go backwards here. MATLAB, the name stands for Matrix Laboratory. So it turns out I can put a matrix of equations in. Let me put one in here. And now, actually, if I do know some LaTeX, and I know a little bit, I can put a little bit in. So there's my pi. But if I want to, I might want to put in something, for example, like an nth root. Now, if I said, let me put 2 of them in. 2, you say, why 2? Because I want to show you something. If I said I want to take the cube root of x minus y to the 17th, did I mean this? Let's put our cube roots in. And let me go x minus y, 17th. Or did I mean x minus y to the 17th? Okay, and those are completely different, right? But if I just say it, or if I write it in words and I'm not very, very careful about how I say it, you might think I meant one thing and I might have meant the other. So it's really nice to embed these equations so that you can show someone your actual intent there. Okay, so I'm back to the point where we want to read in the data, and I had showed you the import file 1. I'm actually going to use a version that I'd already saved, import win function data. It's basically the same thing. Now, if I want to take this and run, I do this like I can run regular MATLAB code. I can run a section. I'll run that section. There's only comments, so nothing happens. And I could go to the next section. There was an advance, but maybe not. I'll just move my cursor over here. And now I can actually run the section in advance. And I do that so often that you'll notice it's grayed out. I could add it to my quick access toolbar because it's sitting right here. And so that lets me minimize the tool strip for right now and go and execute some code. So I'm going to load in the data. And so we've loaded in the data. And here you'll see that this was, if I come back to the live editor, this was in a code section, which is why it's offering. I could switch it to text, but I don't want to. So I can have code or text. Okay. And now I'm going to come to my next section. Actually, what I want to do is clear all my output, which I forgot to do. So the next thing I want to do is I want to come here and I want to make a figure with all my speeds and the figure with time versus temperature, kind of what you saw me do earlier. So what I'm going to do is I'm going to run this section. And when I do, you can see MATLAB had an affordance. It was twirling, it was calculating it. And then instead of popping up a new figure window in MATLAB, it just simply puts my figure right in here. Here's wind data from tower location 1. Now you know why I didn't know what the wind does, because it changes a lot. It's very variable, even through a day or through a month. And then we also have, this is a different data file than I showed you before. This is tower location 1. And in this case, it has the summer in the middle, so it's higher temperatures. You'll also notice that I was able to put some little bit of LaTeX in my label here. So we have the degrees centigrade there. Okay, now if I want to, I could look at the outputs side by side, and I can also shrink this if I want. So I can actually come and I can see by clicking on anything which section it came from. I'll leave it like that for right now. Now, I only have about a little more than an hour with you, or about an hour. And so I can't do the statistics that I really should do, which is I should examine speed sensor 1 separately from speed sensor 2 and speed sensor 3. But instead, what I'm going to do is I'm going to assume that if one of them had a problem, they all had a problem at the same time. Again, not a real valid assumption and not what we normally do, but it's all I'm going to have time for right now. So now I'm going to come here and I'm going to create an average speed profile by averaging the 3 speed profiles. And I'm going to come here. I don't want to clear it. I want to run this. And you see I run in advance. And now I can see whether or not that makes sense, because I can look in my workspace and my average speed is the same length as the other ones. So I did average the 3 speeds from each time step that we have. Okay, so remember what I said before, though. I actually want to think about what if there's some data missing. Well, right now, I said if it's missing, if it's NaN, then I don't know what to do with the data. Maybe I want to interpolate. Maybe you want to delete it. I need to think about it. But where else might I also get data that might not make sense? And I told you, it might be when the sensor's frozen. Well, the sensor's frozen when if it gets water in it, when the temperature is probably 0 or less. But if I think about it being frozen and maybe it went down to -10 and it was really frozen solid, right when it comes back up to 0, it doesn't unfreeze completely. So I might say, let's give it a little room. Let me give it a speed to warm up of 1 meter per second. I'm not sure if that's right, but we can try that. And the other thing is, I'm mixing things up. The temperature, let's say it's less than 2 degrees centigrade. But if the speed is still very high, then it hasn't frozen and I don't want to get rid of it. So I might want to think, well, what if the speed is also slow? So when the temperature is slow and the temperature is low and the speed is slow, those are times when I might want to do something with the data there, because maybe I don't believe it. And what I really would do in the real world, if I had more time, is I might look at the temperatures just before that time step and just after. And I might look at the speeds just before and just after. And I might look to see if one speed is vastly different than the other 2 speeds at a given time. So there's a whole bunch of more intricate things I might do. I'm not going to do that right now, though. In the interest of time, I'm going to choose a temperature and a speed, and then I'm going to find all the temperatures that were less than that specific icing temperature, and I'm going to find all the speeds that are less than my average wind speed that I said was going to be the ice speed. And then when those 2 things are true, those are data I want to look at. Okay, well, this is really bizarre looking code, don't you think? What is that? Well, if I come back to the live editor, what you will see here is that I have something called controls up here. It was right next to when I could switch to code. And I can put in numeric sliders, which is what I have, or drop downs, checkboxes, a whole bunch of things. So I can make this much more interactive, because I don't know what the right number is. So I can come here and I could just compute this right now. Okay. Or I can come here and I can change it. And now we're going to get a new set of things. And in fact, I can click here and we can say, we're saying it's ice temperature. We're going to let you change it between 0 and 5 degrees centigrade in steps of 0.2. And I did a similar thing for the ice speed, but let's put it back at 2 right now, because that's where I think maybe is where we want it for the actual analysis. And now what I want to do is I want to see if I use those, which points are those? And you know what? I'm going to come back here. I'm going to actually do something kind of sneaky. I'm going to clear all the output. And instead of using tower location 1 right now, I'm going to use windata.txt. And now what I'm going to do is I'm going to run a section, and I'm going to come here, and we're going to run in advance, and now run in advance. And we'll get our plot. Okay, and now I'm going to put these back in line, and I'm going to minimize my tool strip. And now you can see I've got a plot here. Well, if I want to see it a little bit better, I can pop it out, but it's not going to change the window inside there. But you'll notice that I have a few, we can zoom in. I've got a few points in red that are candidate points where it's going to be, I'm noting that there could be a problem with these points. So I could just look at those points, or I could do what I'm going to do later on, which is I could just choose to remove those points. Okay, but as I'm doing this, I can come here and let's, we can do the same zoom in thing. No, I don't want to do that. Go away for a second. What I want to do is I want to zoom in, and let me zoom in. And when I zoom in, now let me show you what it's showing me, that I might want to, if I want to always see that span of time, which let's see is December through April, it just created the code for me, so I don't have to guess what it is. And if I want to, I could update my code right there. And so I get the best of interacting with the plot and then committing to code when I'm done. Well, I'm going to come here, and I'm being not very good here. I'm going to reset things. Okay, so there I have the plot that we've got. And I think I had already run this. I had, maybe not, let's see. Everything has the same number of points as before. So I actually haven't come here and taken these particular points where the icing points are ones where I think that the temperature and wind speed are both low enough that I'm suspicious about whether we're collecting good data. And so what I'm going to do is I'm going to run and do that now. Okay, and now I'm ready to come back to the slides for a second, because what I've done now is I've got to the point where I have cleaned up data, and now we can start binning it. And if I want to start to bin it, well, what do you call that? Well, oh, by the way, I can close this now. I'm all done with that. I can come back here and let me open the help in MATLAB. And what I can do is I can look for how to do, we can see if it has anything for binning. Now, that's not really what I want. Okay, what if I do, it's actually called a histogram. And you'll see when I start typing here, there's a bunch of different possible things that I can find. And if we look here, we see histogram. And I'm going to come here and choose histogram. And the help is going to help me here, hopefully. What you'll see is, by the way, I'm running the latest release. It came out last week. And you'll see we give a description of what's going on, how to create it. These are the syntaxes you'd use. And maybe I don't know which syntax I want. One of the best things I can do is come look at the examples. And if there's an example that does what I want, whichever one it is, I can sit there and I can look at the example. And if I want to, I can grab the code and then edit it and put my own variables in. Another thing I really like is see also, because it shows me, first of all, when the function got introduced into MATLAB. It gives me some places in the documentation that I can read more about it beyond the actual reference page. And it also shows me some other functions that might be interesting. Like when I make a histogram by default, maybe it doesn't have enough bins. So maybe I want to have more bins or fewer bins. Or maybe I want to do this on a two-dimensional data set instead of a one-dimensional data set. Got histogram 2 that I could get. So real nice way of finding out more information. Okay, so what I want to do is I want to get a histogram of the data as a function of the wind speed. And I'm going to say I want my wind speed bins to be 0.5. And so that's what I'm doing here. And then what I'm going to do is I'm going to also get the counts, because, let me just run this for you. Here's my wind speed from wind data. Notice how the title actually gets the file name and puts it in there, so we know where the file or the data came from. And we also get these histogram counts. And that's because when I make this calculation or when I make an estimate of it, I need the counts. And I need to also now tell you about turbines. So there's a very brief digression about wind turbine power curves. They all are essentially parameterized around the same way. They start off with you not turning the power on at all. And then they have a speed at which they cut in. And that's because at lower speeds, it's simply the wind speeds don't generate enough power to be worth it. But at the cut-in speed, we start generating power. And you'll see we generate power in usually what's either a quadratic or sometimes a cubic polynomial sort of way, until we get to what's called the rated speed. This is the speed at which the turbine actually gets its rated power. In this case, it's going to be a megawatt. And it's going to stay at that rated power until we reach what's called the cutout speed. Well, if we're getting that much power, why do we stop it? Well, the reason we stop it is when we get to a certain high speed, it becomes very dangerous. And what might happen is we might have hurricane winds. And what could happen then is we could damage the wind turbine, which is a very expensive piece of equipment. We don't want to do that. And worse, if like a blade comes off and it goes flying around the countryside, it could do damage to other buildings or people or livestock or whatever. So we really want to turn it off safely at that point. And then once the wind speed comes back down, we power it back on and we collect more data then. So I need to figure out how to do that calculation. And so what I'm going to do is I'm going to just tell you how I do. First, I'm going to tell you the coefficients that we're going to use for the test turbine. We're assuming they're all exactly the same kind. So the rated power is a megawatt. The cut-in speed is 2 meters a second. Rated speed 14. Cutout speed 25. And now I want to calculate the power curve. Notice I clicked here and that actually ran the section without me advancing now. And because I want to show you this code. So what I'm doing is I could do this in a for loop. So I loop over all the different speeds and you'd be completely, it would be completely valid code and it may be a preferred way for you to do it. I'm so used to MATLAB at this point that I prefer to work on all the data at once if I can, or in big chunks at least. And so what I'm doing is I'm going to take calculate the turbine power bins by saying it's the rated power, and it's going to be dependent on, I'm going to do that power curve, that's the quadratic here. So I'm going to take the current wind speed bin, square it, subtract it from the cut-in speed squared, and then divide by, I'm normalizing this basically, and then multiplying by P rated so that if I happen to be in the rated range, I'm going to get the top speed here. Okay, but that's not true for everything. And so what I need to do is I need to patch this curve. So I need to patch it where the wind speed bins are less than or equal to the cut-in speed. I want the speed to be 0. I also want the wind speed bins that are greater than the cutout speed to be 0. And then in that sweet spot between the rated speed and the cutout speed, I want it to be the rated power. And so in 4 lines of code, instead of a more complex if else if sort of statement with a for loop, I've got my power curve calculated. Well, let's make sure that's true. I like to verify things, and I often do that by plotting, and that's the curve I expect. So that's good. Okay. And now to calculate the average power, if I want to estimate that integral, I can just basically do it by the finite sum of the products. And so that's what I'm going to do here. We're going to calculate the average power. And when I do, you'll see that my average power is 270 kilowatts, which is about a quarter of a megawatt. And I can also compute the capacity factor. That gives me a percentage. So 27% of the power is there now, which is really good, maybe. But I have all these other things that I need to think about, like what are the other turbines doing? Now, one thing that's nice here is I could clear everything out. Let me do that with my magic there. And now I don't have anything in my workspace again. And now if I want to, I can actually, I took the run button and I can run the whole thing, which is really nice. So you'll see it's going to go through. And if we start going through this, you'll start seeing that it may be done already. It's already done. That's how fast it was. Okay, so now if I want to, I could come here and I could say tower location 1, whoops, 1, and we could clear everything else out. And now we could run this one. And when we run this one, we want to come here. You know, if we think about it, there's the data that I was doing this just to make sure that I was doing something sane. So I might not need that later on. And I'm pretty sure later, there's the data. That's pretty interesting. It's actually got a peak at a lower wind speed than our other wind turbine had. But when I look at the wind turbine, you know, this is the same power curve every time. I probably don't need to plot it anymore. I was sort of using that as a visual debugger as well. So I'm not sure that this file is running as efficiently as I would like, because I'm producing plots that maybe I don't need. But right now I have to come in here and edit it by hand. And by the way, the answer here was 19%. So what I need to do is think about, well, how do I want to do this? And so what I'm going to do is I'm going to show you what I did. And I've got a project that I'm running here, and the projects have a bunch of different possibilities, and they let you make shortcuts. And so I've got shortcuts for some of the functions that I did. So I created a function that I took, basically stripped most of the code from the live script here, and I turned it into a function. And here's my wind analysis function 1. And you're going to see it looks very familiar. Here it's got the time, blah, 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 import the data. It's got my figures in here. And in fact, if we come and clear everything out, let's see what this looks like. So let me come here. And so it's expecting a file name. Let's get the capacity factor equals wind analysis. And I'm going to hit tab. I'm going to do function 1. And we want it with the file name, and we want winddata.txt. Let me keep that open. Okay, so what you'll see here is I just got, if we look over at my MATLAB, we see that we got a whole bunch of plots here, lots and lots of plots. I told you I like this one because it's a summary of my data, but I kind of don't really need that one. That was helping me debug before. That was making sure I imported the data correctly. So I don't need a lot of these. And so I might want to think about how to make that a little bit more interesting. And also you'll notice that when I got the information out, it printed all kinds of stuff. And I'm not sure I want all that stuff printed. So what I can do is I can come over to my shortcuts, and we can look at the second function. And the second function, what I've done is I've made it so that the graphics are optional here. So let me clear my workspace out. And now let's come like this. And now let's say we want to run function 2. And when I do, I get a different output, but I don't see very much. Let me, did I clear? Do I have a figure window open? I don't. Okay, so if I want graphics now, I might have to say, I want graphics. And now I get one figure, and it's the data that I wanted there, the summary of the data, the histogram. So what did I do between wind analysis function 1 and wind analysis function 2? I'm going to come over here and show you. So I am in the right folder, and I'm going to do wind analysis function. I have 3, so I need to see what they look like. Okay, so I'm going to come here and select the first 2 functions, and I'm going to compare selected files and folders. And you may not have known this is in MATLAB, but it's actually been there for a very long time. And I'm going to actually swap the sides. This is my new function on the left, my old function on the right. Here's a little key down at the bottom here. You can tell where we've inserted things. the blue, in the tannish color, we can see deletions, and we can see modifications in purple. So we changed it so that there's a possible second input. And then you'll notice we put in an extra line of code here. Now I'm just here I just kept, I changed the reading the data in. I just kept, I did something slightly different with the file name here. Here I pulled it apart instead of keeping the file name as the whole thing. And you'll see in the original file, we had all these plots, and they're gone here now. And then you'll see, once again, we removed some more plots. And then you'll notice that what I did was if the graphics are still there, I make the plot. So I'm amending this area. And then what I do is calculate the probability range, get the information about the turbine, and so on. So I basically have the same information minus most of the plots. And you'll also notice that instead of sending one number out, I'm sending one output out here. So if I come to the top again, you'll see it has one output. It's called wind data. And if we look at wind data, we are now sending a structure out with the capacity factor, but also the updated average speed and all those sorts of things. So if you're working on some files and you have a pristine copy and a working copy, you can compare them from time to time just to make sure they're doing exactly what you want. Okay, now I want to also make this a little bit friendlier, and I'm going to show you what I mean here. Let me clear the workspace out again, and let me close all my figure windows, and let me say, if I come back to wind analysis function 1, we know that it worked if I gave it that file, but what if I accidentally say wind data 1? I get a lot of red ink spilled in my command window. And you might not know, do I start at the top? Do I start at the bottom? This is really a drag. Well, instead of doing that, this is typical me. I go, well, maybe it's actually the problem that I don't need to give it the .text. And so I get a slightly different set of error messages here. Or maybe it's the same one. Or I can say, oh, you know what? I'm doing 1 through 12. Maybe I just need to give it a number. Let's give it 3. Well, no, it can't find that either. And now I'm so frustrated, and I'm just banging on my keyboard, and I get different error messages all the time. Okay, so let me clear out the workspace again. And now let me show you the same things, but with my wind analysis function 3. So first of all, I'm going to come here and actually run it with the data. I have to take the 1 out here. And let's make sure it's still running. Whoops. I'm in the wrong folder, maybe. That's probably what's happened. I'm in the wrong folder. Okay, so it ran. It got me information that makes sense. I got my 1 plot, and it gives me a structure of information back. Now, what happens if I make mistake number 1, where I put an invalid name? It says it can't find that file. Okay, what if I make mistake type 2, where I give it a number? And it says, oh, we were expecting a character, but you gave me a double. Aha, that's a little more helpful. And what if I say, I just don't know what to do? It asks me. How polite of it. And I can come here and say open, and I get my answer. So how did I do that? Well, what I want to do is come over here and come to my project shortcuts, and I want to open the 3rd function, and it's right here. And what I want to do now is I actually want to show you how to figure this out. So what I want to do is okay, so I'm going to set a breakpoint here, I hope. And now I want to run that again. So let me, because I want to know how many arguments it's calling. That's what nargin lets me do. So let's clear this again, and now let's up arrow. And let's follow this one. No inputs. It stops here, and then I'm at the MATLAB prompt, the debugger prompt, so I can say nargin, it's 0. So if it's 0, what does it do? well, let me bring the editor part of the tool strip down now. It says, let me make a step. It's, why didn't it step? Oh, it did step. Okay, it's going to get the names. It's going to ask for the file. I'm going to come here in demos and get that file name. And then we step. And now I'm just going to continue because it's going to go to the end. So I stopped in the debugger and was able to validate something as we went. Well, let me clear this out again. And now let me try one of the other ones. Let's call this with the number, or let's call it with the wrong name, windata1.txt. Okay, so if narg1, well, what is narg now? It's 1. So if I step, we're going to come to the else part of this. And then what it's going to do is it's going to say, is the first input a character row vector? And if it's not, if it is, it says fine, but now look for the file, and I can't find the file, so it tells me that. So I've written this to be much friendlier so that if you go to use it, you're going to get a file, error message that helps guide you and tell you what to do. And if we look again with that file, the differences, I can take the function 3, and now I'm going to compare it to function 1, and we will do the same thing that we did a moment ago. And now you'll see that there are some differences. First of all, we still have the plotting things over in first file on the right. But you'll see the only main addition here is on the left is this big block of code at the front and maybe some white space, and then finishing how we return the output and the structure. So the main thing is I'm putting in handling different inputs, and I'm opening it if I'm opening the file, if I'm getting the file name, if someone selects a file name. Otherwise, I'm checking to make sure that the file name is the right data type. It's actually a character array, and I'm looking to see if it's a file. And if not, I get different error messages depending on what it is. And then once I have a valid file name, I just go into the rest of the code and it just works. Okay, so I am not done yet because we actually said what we wanted to do was figure out which turbine is at the best location, right? And I haven't done that yet. So now that you see sort of behind how I'm doing this, I want to show you my final script here. And I'm going to remove all the outputs that are in it. And now I'm going to make it bigger so you can see it. It's not the one I want. I want this one. Let's clear this out, clear all the output. So if we come back over here, here I have that folder, that WinData files, and you'll see I have 6 files over it. But often when you're doing this, you have hundreds of files. And, you know, I kind of really don't want to think about, I can count them, I can find out the number of files and then loop over that number. But I don't need to think about it that way. I can be more programmatic about it. So what I'm going to do is I want to get all of the files. I want to basically look at all the files that are in that folder here. So I'm going to get the full path to that directory. And then instead of loading the data in, I'm going to create a reference to it. That's what a data store lets me do. So I would encourage you to look up data store in the documentation. And we're saying it's tab delimited, and we're saying that the first input is going to be a date, then one of those date time things. And then I actually have my parallel pool open here. I happen to have a 4-core machine. So let me just run this. And the reason I want to do this is if you think about it, if I have files from a bunch of different files, I can actually analyze them in parallel if I have enough resources here. And so here it's showing me what information there is about this file, and I happen to have 3 files plus 3 more. That's 6 files, and it's telling me how it interprets this. And if I don't like the way that is, I can go and change that, but it's okay right now. And so I'm going to open the parallel pool here now, and it's already there. And what I want to do is that from the number of files, it's going to tell me how many files were in that data store here. And what I want to do is I want to compute the capacity factor. This is with a slightly different version of a wind analysis function here. And what I'm going to do is I'm going to read the capacity I'm going to get the capacity factor for each of the files. Now, what I want to do before I run this is I'm going to bring up my task manager from Windows, and I'm going to come over here and make my MATLAB smaller because I want you to see what happens. So right now you can see I used some CPUs a little while ago, but we're not doing a whole heck of a lot right now. But now I'm going to do this, and I'm doing it in a for loop, but not a regular for loop, a par for loop. It says use all the resources that I have locally in this case, because that's where my pool is. And now what you see is all of a sudden my CPUs got used a whole lot, but they're done. Okay. And so I took advantage of that to unload my local MATLAB, if you will. Now, if you had a lot more files, what you would do is you might have your pool not on your local machine, but on a cluster or the cloud where you have access to more resources. And then you just make sure that it has access to the analysis function and the data. And then you can point to the pool and run that there. So I've done that now. Now I just want to get which one was the maximum capacity, because that's the one where we want, that's the location where we want to place our turbine here. And now what I'm going to do is I'm going to create a bar chart of the capacities as a function of which one of the towers. And you see what I do at the end is I add one more bar for the location that had the best one, which happened to be turbine 4. Now, once I have this, it might be important that I share this information with someone else. And so you'll see here, I can export this, and let's export it to a Word document here. Let's say, here's the analysis, and I might send this report to my supervisor or something like that. Here's what you need to send to the people in the field. Here's the analysis we did. And by the way, if we want to, we could actually create the report instead by hiding the code. Maybe they don't need to see the code, but they want to see some of the details, or they just really want to see this. I can make a report that doesn't have the code in it or has the code in it, either way. Okay, and with that, I'm going to come here and whiz along. I talked to you about MATLAB. I showed you by using what I called what I'm going to call logical indexing, how I could combine and look at all of the wind speeds at once rather than calculating them one at a time in a loop. So that's because MATLAB is a matrix-based language, and you can do those sorts of things really well. There's a lot of functionality, whether it's histograms or regular plots, XY plots, that let you do all kinds of engineering and scientific sorts of calculations. And I started off, if you remember, at the command line, and then I started working in a live script and then a script, and then we made functions. And so I'm working along that whole continuum of programming techniques. And the very last one that we might do would be, I'm not going to go into the details here. If you look in the channel, there will be a location where you can download the code and demos from today, and you'll be able to see this virus demo. And the idea in this one is using different kinds of functions in there. So I can make the code as I did here by putting that if nargin and making my function nicer so that when people got to it, they understood how to use it, because I made the error messages more legible, if you will. And I even made a case that used to give an error with no inputs, do something useful. So I have a lot of the development tools, and I showed you the debugger. What I didn't show you is the code analyzer, but I've showed you a lot of different techniques now. So what is a program? Well, a program actually combines data and algorithmic information. And we can actually take that to a further extreme by letting the program contain, by building a class. This is typical object-oriented notation. When we make a class, what we're doing is we're going to combine code and data, methods, algorithms, and data or properties. And so if I think about it, I have a class. That's a blueprint for the kind of entity I want to talk about. If my class is dog, you can see that I might have different kinds of breeds, the ages, the colors of the dog, and the dogs can do different things. If we then talk about specific dogs, those are objects. We have Lexi here and Luna there. Okay, and those are objects of a class. So the class is a sort of an abstraction, and instances are what are the objects. And MATLAB is fully object-oriented. And again, I'm going to make a little plug for 2 weeks from now when I will be doing a session on object-oriented programming there. But I showed you we could share results from MATLAB. I also could have showed you that we can make apps with using App Designer, but I can share documents, I can share apps, I can share reports like we generated either from like a live script or using something called the MATLAB report generator. And I can also take my algorithms, and if it's just the algorithm, I can use one of the coder products and make it available so it can be used in a different system where MATLAB doesn't exist at all. And it can be even an embedded system. Or I can choose to take my entire application, including any graphics and any applications that I make, and using the MATLAB compiler or the MATLAB compiler SDK, I can have something that actually makes an app that's a web-based app. I can make it possible to link your app in a situation where you're going to use resources that may be in other languages. So there's a lot of ways I can take the information from MATLAB out and use it, repurpose it with other tools. And I'm not going to go through here. I'm just going to zoom to the end. Yeah. So hopefully today you got the idea that MATLAB is a high-level language. It allows you to have the best of all the worlds with both programming and a lot of interaction, and interaction that generates code for you. I showed you a lot of interactive development tools, the debugger, the editor, the live editor, and things like that. And I showed you that it supports a range of programming styles. And thank you. And then I'm just listing some of the tools we talked about. We did data visualization. We didn't use the profiler today, but we did a lot of different we showed a lot of different ways of looking at the tools. One last thing I want to leave you with, and I'm going to come back to my MATLAB to show you this. In the help, if I come back to MATLAB here, I can look at the release notes. And when I look at the release notes, you'll notice that this scroll bar is teeny tiny. And it's a little bit intimidating. Well, I can come over here and I can say, well, you know what? Right now, whoops, let me come here. Right now, we're looking about the changes from 18B to the current release. Suppose I actually was most recently using 19B. Well, that may make it a little bit better. It's still pretty long. But now I can also come here and I can say, you know what? I really care about the math and the data analysis. And when I do, you'll notice that I have a much smaller scroll bar here, but maybe still a little bit long, but I can start seeing, boy, there's a lot of new stuff in there. That's kind of cool. That's one way to learn new things. If you don't yet want to learn some new things, though, I can come here and I can say, I just want to check for incompatibilities, anything where it may cause a problem for me. So now I come here and we look and we see, and I go, I never used a timetable before, so that doesn't matter. So those are good. So you can go through very quickly and assess what's new, what's interesting, what you want to delve into more, and what might have changed that might be worth looking at. And with that, there are a lot more resources online. There will be, this video will stay up on YouTube, so you'll be able to listen to it again. And with that, you might also want to take the MATLAB training course, MATLAB Fundamentals. And if you've never used MATLAB before and you don't have access to MATLAB yet, you can go to our website. You need to create an account, and you can use the MATLAB on-ramp, and it will give you 2 hours online free tutorial for you to begin to learn how MATLAB works. And that would be a great way to get started. And that's it. So hopefully you have learned a bunch. I think we're starting soon again with the Simulink Student Challenge. I'm not sure about that. I think it's coming up. Anyhow, we have a bunch of competitions. Go to our website and see what's happening, because you might want to join that. I know it's also the 20th anniversary of our community pages, so you might look there as well. And also subscribe to the MathWorks channel to get reminders for next events. And I look forward to seeing you in a couple weeks. Thank you.